Take a minute of your time and imagine the world without mathematics. Teaching platform, this is Mr. Mlonga, aka the teacher. My pupils calls me the teacher. We are here to do mathematics indeed. Be ready for the lesson that is coming forth. If you are new to this channel, you are welcome. Please subscribe so that every time we post a video, you are the first to be notified. We'll be posting videos every day. I'll basically talk about 4 methods of solving these systems of equations. One of them is the matrix method. So we'll start with the matrix method. Then we'll go to elimination method, substitution method, and graphical method. So we start with the matrix method. We say solutions. Using the matrix method. To use the matrix method, you first come up with the matrix equation, where you consider this side, you consider the coefficients, like the coefficient of the first variable x is 2, so write 2. The coefficient of this y is -1, so write -1. The coefficient of this x is 1, so write 1. The coefficient of this y is -2, so we write -2 like that. Then the variables that we want to find are we'll start with x. We'll say x, y equals, the answers will give us a column matrix. So we have a column matrix in this position, that is 5 and a 4 like that. At this point, you have come up with what we call the matrix equation. From the matrix equation, the next thing is to find the inverse of the coefficient matrix. Our coefficient matrix is this one. This is our variable matrix, and this is our answer matrix. The coefficient matrix is this one. So let this be equal to A. We say let A be equal to this. That is 2, then -1, 1, -2. After that, find the inverse of this matrix. For you to find the inverse of this matrix, we are saying inverse of matrix A is equal to 1 over determinant of A times A adjoined. I will explain all this. So 1 over determinant. This stands for determinant. So first of all, let's find the determinant of this matrix. Determinant is equal to product of the major diagonal minus product of the minor diagonal. So in this case, what we have 2 times -2 minus 1 times -1. This is our major diagonal, this is our minor diagonal. So product of the major, product of the minor. Do not make a mistake there. The major diagonal, product. The minor diagonal, product. So you subtract the minor from the major. Then from here, this is going to give us 2 times -2 is going to be a -4. Then minus 1 times -1 will give us a -1. From there, this is now going to be a -4 plus 1, which will be -3. Then we can be able to find the A inverse now. So our A inverse here is going to be, therefore, A inverse is going to be equal to 1 over -3. Then the adjoint of matrix A, in this case, these two, -2, takes this position. This +2 takes that position. So we interchange the positions of the numbers that we have in the major diagonal. And we have a -2 here. This becomes a +2. There, we change the signs. So if this is a negative here, then it will be a positive there. This is a positive there, it will be a negative here. So we have this, our inverse matrix now. From here, multiply both sides of this matrix equation by the A inverse. So we are saying -1 over 3, then -2 there, -1, then 1, 2. This is our inverse matrix. we have to multiply it to everything that is there. So we multiply it to this, that is a 2, negative 1, 1, negative 2, like that, then x, comma y equals, we said you multiply throughout the matrix equation, meaning even the other side you still have to say negative 1 over 3 times this, negative 2, negative 1, then 1, 2 times the column matrix, which is 5, 4. 5, 4, like that. From this point, we'll continue upwards there. So let's say from this point, we move in this direction, we go this direction. So from that point now, when you multiply this side, let us just keep this one the way it is. We have to say negative 1 over 3, negative 2 times 2. It will give us a positive 4. So we have 4. 1 times 1 will give us, this is not a negative 4, not just a 4. 1 times 1 is going to be plus 1. We are using the concept of row by column. So in this case, this row must multiply these terms to get the first term. So we have negative 2 times positive 2, giving out a negative 4. Then 1 times 1, giving out a positive 1. So row by column. This same row must multiply the last column that side. Negative 2 times negative 1. That is we are saying negative 2 times negative 1. That is a positive 2, like that. Then 1 times negative 2. That is a negative 2, like that. We have multiplied this row and all the columns in the second matrix. Then we come to this one. Negative 1 times positive 2 is negative 2. 2 times 1, positive 2. So plus 2. Then from there, we are going to multiply this same row, times the last column. Negative 1 times negative 1 is going to be a positive 1. So we have 1. 2 times negative 2 will be a negative 4. We close the matrix, then x, comma y, then equals negative 1 over 3. Negative 1 over 3 is this one here. Negative 2 times 5 is going to give us a negative 10. So we have negative 10. Then we have a negative 10. 1 times 4, positive 4. Negative 1 times positive 5, negative 5. 2 times 4, positive 8. Like that. At this point, we have multiplied the inverse matrix throughout the matrix equation. But this is not the end. We still have to work out what is inside the matrices there. So we are saying negative 1 over 3, then negative 4 plus 1 is going to give us a negative 3. So we have a negative 3 in this position. Remember, you have to move negative 4 steps on the number line, then 1 step to the positive. So it will give you a negative 3. 2 minus 2, 0 in that position. Negative 2 plus 2, 0 in that position. 1 minus 4, negative 3 in that position. Then x, y, like that. Negative 1 over 3, 10. That is negative 10 plus 4, negative 6. Negative 10 plus 4, negative 6. Negative 5 plus 8, positive 3, like that. Okay, have you seen it's reducing as we move on? Then, at this point now, let us multiply throughout by the scalar, this. When we multiply, When we multiply negative 1 over 3 times 3, it means negative times negative will be positive. Negative times negative is positive. 1 over 3, that is, we are saying negative 1 over 3 times negative 3. That is for this position, because we have to multiply everything inside the matrix by the scalar. Then negative 1 over 3 times 0. Negative 1 over 3 times 0. Then we close like that. Negative 1 over 3 again. Negative 1 over 3 times 0. It's okay, even if we use the brackets or the multiplication, it's still the same. Negative 1 over 3 times negative 3. Negative 1 over 3 times negative 3, like that. Then we have our variable column matrix. So x, y equals, multiply through, even in this position, you have a negative 1 over 3 times negative 6, negative 1 over 3 times 3, like that. At this point, negative times negative is positive. So negative, negative, positive. 3 and 3, they will cancel. So you just have 1 in that position. Any number times 0 is 0. Any number times 0, 0. Negative, negative, positive. 3 and 3, they will go. 1 in that position. Then x, y equals this negative, negative, positive. So 3 into 3, 1. 3 into 3, 3 into 6, 2. Not 3 there. So this will be a 2. So we have a 2 in this position. Then negative times positive is negative. 3 and 3, they will cancel. So we have 1 in that position. This side we are done. We are remaining with this side. The moment you reach this kind of a matrix, we call it the identity matrix of multiplication. Okay, so the moment you reach this matrix, if you are able to reach there, then you should be actually clapping for yourself, because it means that what you are working out this side on the left is correct. Okay, so then we say we can still multiply 1 times x, that is x. 0 times y, that is 0. 0 times x, x. 0 times 1, that is y, equals 2, negative 1, like that. X plus 0, x. 0 plus y, y, equals 2, negative 1. At this point, the equal sign shows that what is this side is equal to what is there, meaning x is equal to the first term. Therefore, x is equal to 2, y is equal to the second, and y is equal to negative 1. These are the answers. So x is equal to 2, y is equal to negative 1. You can do a proof to just be sure that what I've been doing is correct. We can do a proof. We say a proof. You pick one of these equations there, anyone, or if you want, you can start with the first one, then you go to the second one. Let me try to start with the first one, then we'll go to the second one. If you start with the first one, 2x, x is equal to 2. So we are saying 2 times 2, then minus y. Minus y, our y is negative 1. So minus 1 equals 5. 2 times 2, 4. Negative, negative, positive 1 equals 5. Therefore, 5 is equal to 5. Hence proved. If you want, you can also use this one. You say x is equal to, x minus x minus x minus 2y, our x is known, so we write 2. 2 minus 2y, 2 minus 2 times negative 1 is equal to 4, because 4. 2, negative, negative, positive 2 equals 4. 2 plus 2, 4 equals 4. Hence proved. This is how we solve simultaneous equations using the matrix method. This marks the end of our lesson. Please, if you have not subscribed, this is the time to do so, because every day we'll be posting videos, and it's important that every time we post a video, you are the first to be notified. Where you need to comment, you need to ask something, do not hesitate. We value your support, we value your contribution, be it positive or negative. Welcome once more, and thank you very much for having watched the video. Please share the video with others. Let other lovers of mathematics enjoy the mathematics that we are doing on this platform. It's mathematics all the way until Jesus Christ comes. Take a minute of your time and imagine the world without mathematics. We cannot be able to calculate or count the time without the use of mathematics. The calendar that we use is a product of mathematics. We only get to know that this is the year 2020 by the use of mathematics, by following the calendar mathematically. The population of any country is a product of mathematics. You only get to know that it takes 9 months for a baby to be born through the use of mathematics. In the medical field, temperature is calculated using mathematics. In the business world, profit and loss is only appreciated by the use of mathematics. A bricklayer uses mathematics to calculate the number of bricks needed for that construction. A carpenter uses mathematics to calculate the gradient of the roof before the roof is put up. A policeman has to count the number of prisoners in that police cell through mathematics. A thief should be able to calculate the hypotenuse of that brick wall before falling off that brick wall. We all need mathematics. Mathematics runs the world.